Countdown starting now. 60. 20. 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, launch.
I'm actually excited, a little bit nervous. I mean, I get to press the start auto sequence button, but I mean, we've tested the system so many times. I'm confident everything will go right.
Yeah, Asri does two things. We build rockets and we build rocket scientists. So our job is to develop technologies, advanced aerospace technologies for South Africa, and then also to build the talent pool, the people that can sustain a commercial space launch capability. The Phoenix program does three things. It provides a flight test platform so that we can test new technologies, because we're aiming to develop a commercial satellite launch capability, and you can't do that in one step. You have to develop the technologies first, and you need to test fly them, and you need a relatively inexpensive platform that can do that, and that's where Phoenix comes in. So the first thing is flight development, test development. The second thing that Phoenix does is it's a human capital development program. So hybrid rockets are really good for the development of young engineers learning how to build rockets, because they contain elements of both liquid and solid rockets in their design architecture. And the third thing that Phoenix does is it allows us to talk to the public and involve the public in rocket launches. And that is critically important, because if we are going to go to space as a country, we have to bring the country along with us. And that requires that the country understands what rocketry is about.
Phoenix 1D is what we call the racehorse rocket in the Phoenix series, and it's designed to be the best performing rocket we can come up with. So it's got the lightest components, it's got the most structurally efficient components, and it's all geared towards achieving the highest flight speeds and the highest altitudes. It's really all about testing the technical limits of our design and manufacturing capabilities. Phoenix 1E is more of a workhorse, so it's primarily designed to carry payloads up during the flight.
The 1E rocket, the payload, they have a stack of payloads. From the top down, it's sensor, and we have ESL, University of Stellenbosch, and our industry partner, Max IQ payloads. So all of us can be transmit individual telemetry data from their base station.
And the other element that was unique to 1E was our attempt to recover the payload module following the flight of the rocket. So 1E is designed to have that element of recoverability to it as well.
When you launch rockets, you have to be really careful where they end up. So it's an exercise in safety. And one of the reasons we test at Overberg Test Range is because they have control over their airspace. So when we launch from LPOA, we do that because it has all the necessary equipment, the facilities. It's a licensed launch pad. And it's also a good place to launch the rocket because it's going to go from there out to sea in most cases. So we plan our trajectories from LPOA, and we make sure that we keep the rocket away from people and safe, and that we get the optimal results from the test.
My name is Yashik Singh. I'm an engineer with Asri, and this has been my third Phoenix launch campaign. A lot of work went into those days preceding the launch. We've actually split into multiple teams. So we had a recovery, avionics, and telemetry team. we had a controls team, and then the gantry team, which ultimately became the vehicle assembly team.
My name is Jason. My role is a ground sports engineer and gantry operator. So my main role is making sure that the gantry is operating as it's intended to do, making sure that we put it in the loading position and things like that, and in the launch position, correct launch angle and so on. Then in addition to that, all the ground support equipment, so connecting up all the service units to the gantry so we can ensure a smooth filling and smooth operation of the gantry, checking for leaks in the system, running connection lines, running electrical cables and things like that, performing systems checks and ensuring everything is working as intended.
I am Tobisi Chomela. I'm an engineer at the Aerospace System Research Institute. So this was my third campaign that I attended.
So my role is doing the recovery system for the rocket, nose cone, and also making sure that I design a structure that will fit the payloads or scientific experiments that will fit inside the rocket.
So over the 3 days, there was a lot of things happening simultaneously. So the avionics team was sitting in the telemetry building for the 1D rocket. They were working on sensor packs and telemetry so that we could actually get a streaming of data down from the rocket. Then the gantry team becomes the vehicle assembly team. So once we're done with setting up the gantry, we go set up the rocket. So we connect the rocket motor to the oxidizer tank. And then finally, once the avionics and nose cone team is done, they bring that to us, and then we assemble the whole vehicle and then put it onto the rail. The controls team is in charge of the LabVIEW system, and that deals with communicating with all of the hardware, controlling it. So they need to set up that, make sure the control loop's all fine. So if anything goes wrong, the control system can deal with it. There's a lot of critical things that have to come together when you're integrating systems and doing systems checks. We do subsystems check, and then we perform a wireless communication with the rocket itself, and then rerun a complete systems check to make sure that everything is ready for launch.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Launch. Rocket has launched.
My highlight would be the sequence of events leading up to launch, which includes an intense countdown period that shifts into the roar of Phoenix launching off the rail, which contrasts the emotions of tense to relief and then finally joy.
So for this launch campaign, I was positioned in the control room, and the main highlight for me was to see or witness the stage separation. That was the main highlight for me, and mainly the excitement and the celebrations it brought about to everyone who was there at the control room.
Seeing it on YouTube and watching videos, it's nothing compared to seeing it just shoot into the sky and you see it. Absolutely beautiful. One of the best experiences I've ever had in Loudon.
Day 2 was all about STEM for the school kids who visited us, and formally unveiling the South African Sounding Rocket Launch Facility at Pad LPOA at Overberg Test Range. And so the South African Sounding Rocket Launch Facility was commissioned, was designed and developed by Asri in collaboration with commercial partners, funded by the Department of Science, Technology and Innovation, and it gives to South Africa a unique capability to launch suborbital rockets from Overberg Test Range.
Involving school children is really part of the fundamental role of encouraging STEM as part of what we do. It's important for the university, it's important for Asri, it's important for our sponsor, DSI.
So during the campaign on the Tuesday, which was one of our off days, we did have a STEM outreach program where we had 3 events planned for the kids. The first event was a stomp rocket competition where the kids manufactured a rocket made out of cardboard and a launcher made from PVC pipes in a 2-litre bottle. While we were outside there, we also had a drone demonstration where one of our team members, Yashir Ghazi, who is a professional drone pilot, he then did a test run with all of the kids, which kind of blew their minds. And then to finish off the STEM campaign, we had a glider competition.
It's day 3, Phoenix 1D launch, and we're T-minus a few hours from launch. We're just doing final checks, and nose cone should be going on, and then we're gonna start fueling, and hopefully we get a successful launch.
So my name's Tyron Swanepoel. I'm an engineer at Asri, and this is my first launch. With the rockets, in order to get a good tracking to actually be able to visually see using the radar system, you need the right combination of materials. So a variety of materials were used on the rocket to ensure that it was visible to the radar system so it could accurately track it during the full flight profile. With those radar systems, it was also coupled with the theodolites, which are visual tracking systems. So with that, we were able to actually see the nose cone separation and then combine that with our onboard flight computer.
My name is Sarisha Harilal. I'm an engineer at Asri, and I've been to 3 Phoenix campaigns. So the flight dynamic simulations that we perform provides us with the trajectory, the nominal trajectory of the rocket, and so we have an idea where it will land. However, no manufacturing technique or design is perfect, and there's always uncertainties in the design. So we perform Monte Carlo simulations that incorporates these uncertainties to provide us with a footprint of all the possible landing sites. And so therefore we ensure that we have a safe landing zone.
We had a failure effectively just before we had to push the go button. We had overheating in the payload module compartment of the vehicle, and that unfortunately shut down the electronic systems. So we really wanted to get data from that telemetry radio, and we really wanted to see activation of the FTS system, but our power delivery system failed because the rocket was on the pad for quite a while, overheated, and unfortunately there's nothing we could really do about that. We had to go anywhere, we had to fly.
That is so
Okay, this campaign was my first one. I was excited to be there. It was an emotional journey for me because it's not something that happened daily.
I was stationed on top of a hill not too far from the actual launch pad, so I got to see the launch in person, see the rocket take to the sky, and you could hear the sound delay. It was a really profound experience because rocketry is what I've always wanted to do. I started building hobby rockets since high school, and I always knew that I wanted to be a rocket scientist, so here I am. Asri is giving me that opportunity.
Getting to experience the rocket launches at OTR, it's really given me a better appreciation of all the engineering work that goes into it, from design to preparation, and I really enjoyed being able to view that and to be a part of it. So that really helped to sort of get me to the end of that decision and decide to become an aerospace engineer.
My name is Jordan Silver. I'm an engineer at Asri, and this was my second Phoenix campaign. There were a few procedures that we implemented into the nose cone to try and maximize the chances of recovery, since it was a small item that we were trying to recover. So one of the things that we had was I had a Yagi antenna which tracks the flight computer inside of this nose cone and was able to give us the final coordinates when it hit splashdown. So these coordinates were then plugged into our GPS and we were able to try to get there within about 15 to 20 minutes to try and hopefully identify a C dye which we had implemented at the base of the nose cone, which was a slow release, high, bright yellow dye to try and increase visibility.
We had intended to collect the nose or to recover the nose under a parachute using a boat that we had dispatched, but it could not find it. So about 10 days later, the nose was discovered off the southern Cape Coast by a fishing vessel that retrieved it from the water. And of course, it had been floating there for quite a long time, and we expected there to be a lot of damage to the payloads. But somewhat miraculously, we were able to retrieve camera footage off the cards that were in the payloads, and the South African National Space Agency was also able to retrieve magnetometer data from their payload, which was on the rocket.
We have an incredible team of engineers at Asri, and it's probably one of our biggest strengths. Designing a rocket is not simple. Operating a rocket is not simple either. It's very multifaceted. So our team really has a set of skills that have been honed to support rocket design and rocket launch.
The team works really well, I think, because we all share the same vision for rocketry. We share the same passion. So we've never had any issues working together because there's always that drive, whether we have to be at the range early or work till really late. I think it's only when we get hungry that, that's when the problems arise.
2024 was a phenomenal campaign for Asri. We managed to successfully launch 2 hybrid rockets. We got great data from both of those launches. If you consider the technical achievements of this campaign, 2 successful rocket flights, recovering data from the payloads of 1E, the formal unveiling of the South African Sounding Rocket Launch Facility, and also the educational aspect where we involved multiple high schools in the activities, this was easily the most successful campaign yet.